Check, check. Check my fart. Is my microphone working? I want to say it's working. Okay. Um, we're on a little bit early, so give me 1 second. I'm gonna go ahead and share this. Let's get it out there real quick. Link to me. All right, all right, all right. All right. Don't want to take too long. Let's go ahead and get right into it. So, hope you guys had a good weekend. I didn't really stream last week. It was my anniversary week, so I was just spending time with my girl, kind of kicking it, enjoying life a little bit. But we're back to doing the whole thing. Um, yeah. So if you guys are new to this, welcome to Silicon Made Simple. This is a beginner friendly tech YouTube channel where we kind of just discuss a lot of easy to understand concepts. And then sometimes we'll take a lot more harder to understand concepts and break them down as a team so that you guys can understand them. Later on, we're going to be developing into talking about all kinds of things like quantum computing and what a supercomputer is and a lot of things that are beyond the scope of, I guess, the normal understanding of tech. But for now, we're starting off slow. And if you guys aren't up to speed, go ahead and go on the channel and watch our previous streams because in our previous streams, we did a pretty thorough job of breaking down PC components like piece by piece. Um, and so in those past streams, we kind of explained what the RAM is, what the SSDs are, what the cooler is, what the GPU, the CPU case. But we're gonna go really, really, really deep into that today. Um, and the goal of this stream is for you guys to be able to use this as a complete understanding of how to go out there and shop for PCs yourself. Because not only is it super fulfilling to be able to build your own PC system, but it honestly has so much more longevity to it and it operates so much better than any pre-built that I've had. I've even, tried to stray people away from buying pre-builts and they didn't take my advice. And then later down the line, end up calling me, hey, bro, can you come fix my computer? It ended up breaking. But my system back here has been running for almost 4 years now. And I use it every day gaming, work tasks, normal tasks. So it's a productivity and gaming beast. And I've had absolutely no issues with it whatsoever. Um, the only thing that really goes wrong is occasional, buggy drivers and stuff like that. But that's a Windows operating software concern and less of the actual, your choice of assembly of PC components concern, right? So let's go ahead and get right into this. I want to go ahead and share my screen because we're going to watch a video together. And then I'm going to show you two sites, two very, very important sites that I like to use. One of them is a GPU comparison tool. And so you can, if you're on the verge of like picking between NVIDIA and AMD or two different NVIDIA generations or two different AMD generations, whatever. But let's say you get into the scenario where you have two GPUs on the table. You can really use this tool and it's going to basically benchmark it and break down all the things about it as far as the shaders and how the GPU works internally, and it's going to give it like a score, and then you can compare them numerically, which is really cool. Um, so yeah, what we're going to do is I'm going to share my screen. My bad. Let's share my entire screen and audio. Okay, so uh, my bad. I'm logging in from another device just in case anyone's in the chat. Okay, cool. Now I can see that. All right. Let's go here. And right here.
This is a slate. This is a pizza. A slate lets you modify, customize, and combine its features. Because who knows what you'll be craving next? Slate, we built it, you make it.
Cores.
Okay.
Cores are like the brain
It
cell.
starts very abruptly. So let's break it down. It's gonna start with CPUs and it's gonna go down all the essentials of the internal of the CPU. So remember when we talked about cores and we talked about threads and we talked about all the important things inside a CPU that actually make it calculate its calculations. This video has some graphics and it's explained very, very clearly. So I love this. Let's watch it together. And I will pause and clarify maybe 2 or 3 times, but it's a short video anyway. So I think you guys will understand most of it.
Of your computer's brain. One core can think about one thing at a time, kind of like trying to read a book while cooking noodles. Add more cores, and suddenly your computer can do both at once. Modern CPUs have multiple cores, 4, 6, 8, even 16, each.
Okay, so modern CPUs have multiple cores. So you're gonna see here when we go and we're choosing CPUs, right? Let's look at the Ryzen 7 9800 X3D. This is gonna tell you its actual specifications, right? So this is what you want to look for when you're shopping for a CPU. You want to look for its microarchitecture, its socket type, its core count, and its thread count, because these types of things. Oh, and the L2 and L3 cache is important, especially if you're running HD gaming. But all these things kind of combined um, are how you gauge how powerful the CPU is, right? So in theory, the more cores, the more threads, the more power. Let's keep it going.
Handling a separate task. That's why your game runs smoothly while Chrome eats half your memory in the background. If your CPU were a kitchen, each core would be a separate chef. More chefs mean faster dinner, unless they all try to use the same stove. That's where smart coordination comes in. And that's why multi-core CPUs rule.
Right.
Threads.
So multi-core CPUs are very, very, very essential if you're doing a workstation like me. If you want to stream like I am right now, you have to have a multi-core CPU with, I would say, at least 8 cores. Um, what CPU do I have? I have the 13600K. So if we look that up real quick, let's see how many cores I have. I can also show you down here because I have this thing called Core Temp, right? So this is a cool app that lets you monitor the temperature of your CPU. I don't want the new version because it sucks. And this is actually going to tell you a little bit about your processing unit, right? So let me see if I can make this bigger. Okay, the software is not up to date. But as you can see, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14 cores and 20 threads, right? So that's a mixture of the P and E cores. Remember, I told you guys about the primary cores and the efficiency cores. So I do not have a 14 primary core CPU. That would be absolutely ridiculous. I believe this one has 8 P cores and the rest are E cores. So it has a good amount of power when it comes down to productivity, and I can multitask pretty seamlessly. I really don't have any trouble when I'm doing things like this where I am watching videos and streaming. I've even streamed gaming before. This thing is an absolute beast. I have had no issues with this Intel CPU. So let's go on to threads now.
Threads are the secret clones of each core. Imagine every chef suddenly learning to work with two hands instead of one. That's
Mhm.
threading. Each core can juggle two tasks by splitting its attention between them. It's not true multitasking, more like switching between tasks so fast that it feels simultaneous. Intel calls this hyper-threading. AMD calls it simultaneous multi-threading. Same idea, fancy names. Threads make computers better at handling lots of smaller jobs, like running background apps while you're gaming. Think of it as having workers that drink way too much coffee and never stop multitasking. That's what gives your CPU its smooth, responsive magic. Clock speed.
Okay, so threads is pretty similar to cores in the sense that it directly relates to how smooth and how fast your system can operate. Um, I would say the main difference is whereas cores is like the amount of cooks, the threads is like the amount of tools that they have, right? So the more tools that they have, the the more efficiently they can do their job and they can process data at a much higher rate than a CPU of its competitive nature that wouldn't have a higher thread count or as high of a thread count. So these cores and threads, again, in with the primary cores and the efficiency cores and the threads, get up to very high numbers, like the AMD Threadripper. Let's show you guys that real quick. I don't need a new tab, but shout out to these E cores and threads. These tabs will not slow me down. So look, I want to show you guys this one real quick. AMD Threadripper. This is their workstation CPU. So it's like, what you would use for extreme projects. Maybe you're like a NASA engineer or a movie editor or an artificial intelligence engineer or machine learning engineer or something like that. And you need extreme power because you're running fast commands and billions of them at a time. You can get up to these Threadrippers. So that kind of explains it. Let me just show you what it is. All right, here, let's go on this. I think they have it. They should have it here. Type in thread. Right, AMD Threadripper. See, 64 core processor. Now you'll see the price is 2,700, but that's because you're paying for that amount of compute power, bro. It's absolutely insane. Different microarchitecture, not compatible with the pin grid or land grid array that I spoke about previously. Um, So yeah, that's kind of a good. But if you're doing a Threadripper system, you also need like a motherboard that's compatible with the Threadripper CPUs, and they are absolute monsters. I haven't actually built any Threadrippers or any CPUs that have a 64 cores and 128 threads, but like think of how much my computer can do with its 14, how many cores do we just say? You know what I mean? Like you don't need that much to do a lot. So that's just to kind of give you a scope of understanding when it comes down to what threads actually do. And cores and threads in conjunction with one another is kind of the direct solution for a CPU speed. Clock speed.
Clock speed is your CPU's heartbeat, how fast it ticks, thinks, and gets things done. It's measured in gigahertz, or billions of tiny pulses per second. Every tick is a moment where your CPU performs an action, like moving a file, calculating damage in a game, or loading your cat memes faster. Higher clock speed means more work per second, but also more heat, like running faster on a treadmill. Great for performance, terrible for sweat. Modern CPUs balance their speed automatically, slowing down to save power, or speeding up to handle heavy tasks. So while clock speed matters, it's not everything. It's the rhythm that keeps your CPU's world spinning. TDP.
Got it. So now a lot of this stuff, a lot of that might have sounded repetitive where you're like, well, what's the difference between clock speed and, all these other things? Really, clock speed is the measurement of how your CPU runs. And there's a formula for clock speed. So if you just search in clock speed calculation, right? How many calculations the processor can perform per cycle. So let me actually, yeah. So when I was taking CompTIA A+, we actually learned about this. This was one of the first things. Um, you just run through this real quick for you. So the clock speed is the number of tasks performed in 1 second, and the clock cycle is the CPU speed in the number of cycles per second. So what does all that mean? It's kind of like the math of how fast your CPU is. So when you go back to, let's go to a realistic CPU. I don't think anyone's in the market for a Threadripper right now. Let's say you're looking at a Ryzen 5 5500, right? You're going to see this, you'll see the cores and the threads, and then you'll see the performance core clock, performance boost clock. That is the clock speed. So it's how much it can calculate in 1 second, for lack of time to explain it more in depth. But pretty important. It's more important if you plan to overclock your CPU, and overclocking is basically manipulating the software against the manufacturer's recommendations to allow your CPU to perform at a higher rate. Um, Honestly, not recommended unless you are very experienced with PCs, because not only does it ramp up your TDP, which we're about to talk about next, that means you need more cooling power. So there's a lot to consider when you're thinking about overclocking your CPU. Most of the time, it's not necessary. I've never done it. And again, I've played 4K on here, no problem. So
TDP stands for thermal design power. But let's be real, it's just a fancy way of saying how hot this thing gets when it's working hard. It's measured in
you're
watts, like a light bulb, but instead of shining, it's screaming internally. A CPU with 65 watts TDP runs cooler and uses less power. One with 125 watts? It's basically a space heater that can play games. TDP helps you choose the right cooler and power supply.
Mhm.
Because if you pair a high TDP CPU with a weak cooler, you're basically hosting a barbecue inside your case. More
Don't do
watts
that.
mean more speed, but also more heat, noise, and possibly regret. Cache size.
TDP, how much power? More power, more hot. More hot, more cooling required. Not enough cooling, too much hot, burns computer. Next.
Cache is your CPU's secret stash of memory, the ultra-fast snack drawer it uses before running to the slower kitchen. Your RAM. When your CPU needs data it uses often, it keeps it here, right next to its brain. Think of it like a student who keeps snacks within reach so they don't have to run to the fridge every 5 minutes. Cache comes in levels, L1, L2, L3, each a little bigger but slower than the last.
Cache is very similar to RAM. So if the RAM is the memory of the motherboard system and the operating system, your cache is the memory of the CPU itself.
It's tiny but mighty, the difference
Again, we
between
talked about
instant
RAM
action and hang on, let me think.
last week's stream,
Architecture.
or the week before
Architecture is
that.
the blueprint of how the CPU thinks. It's the difference between a medieval castle and a futuristic skyscraper, both built for living but totally different inside. Intel, AMD, and Apple all design unique CPU architectures that change every few years.
Makes sense. So the architecture is basically, because the CPU has it's like a mini PCB board, and it's got all these transistors and the cores and threads running through it, and how that board is actually designed and how those transistors are laid out, how many of them there are, where they're put, and in what fashion drastically changes the performance of the CPU. So your Intel core, which we already spoke about, is your pin grid array, or your land grid array. LGA 1700 is the socket that my motherboard uses. These are PGA, and then Apple M1 is a little bit different. They have proprietary CPUs, and lately the Apple M technology, like in the Apple MacBook Neo that just came out, is absolutely incredible. And for that price point, they are going to move units.
These blueprints decide how instructions travel, how data moves, and how efficiently power is used. It's not just about speed, it's about smart speed. New architectures usually mean smaller, faster, cooler chips that do more with less. Think of it like a
So, like he said, newer architectures that we're going to see develop, essentially what we're trying to do is shrink more and more and more, because the more nanometers and the more things that we can fit inside of one tiny space, the more power it actually has when it's sending these binary codes to and from the receiving end of whatever is happening in that transfer of information. So, um, the architecture will change and it's going to keep getting better and better. And as you require more computing power, your architecture of the CPU changes, it might get a little bigger. Threadrippers, for example, are bigger in size physically than your typical i5, i7, i9, or AMD Ryzen series CPUs, right? So I'm actually going to do an episode where we open up a MacBook and I open up a regular When I say regular, I mean an HP laptop side by side. I'm just trying to acquire a MacBook that nobody cares about. So if you guys have a broken MacBook that is like just fried and has no use, please let me know. I would love to get it from you one way or another because I'm looking for a MacBook that I can open just to show people the difference between the inside of a Mac and an HP or a Windows laptop. Windows. Windows doesn't, you know what I mean. Um, so, with that being said, if you guys have any questions, please go ahead and type them in the chat. But if not, we'll go ahead and move on to the first website that I love to use when I'm doing PC research and when I research my PC parts, called PC Part Picker. Now, the reason I love this site is because it breaks down everything that you need to have a full setup no matter what. So, the first thing you want to do is do your homework and understand what you're trying to get. Do you want a computer that you can just kick it and go on the internet on, maybe watch some YouTube, travel around with, whatever? You might be looking into a laptop. Still helps to understand the components. But if you're looking for a PC that has a little more power, let's say maybe you want to have a workstation where you're going to be editing, or you're going to be doing a lot of AI stuff, or you're going to be playing games, or a combination of those things, you're going to want more power, right? So really, building a system comes down to you understanding what you want out of your system, because you can spend as much as you need to get the compute power that is necessary for your tasks, right? So again, you're going to be using things like your understanding of clock speed and your understanding of CPU architecture specifically, because that really kind of breaks down the whole what's the right word, the whole build of your system, right? So we'll go to CPU first. When you're coming here, you're going to go here and you'll have your options of, I mean, really, there's only two options on the market right now, right? You have Intel and you have AMD. Intel is phenomenal. They are, a legacy company. Still have good driver support. I have had no issues with mine. Like I said, I have a 13600K and I absolutely love it. By the way, you might notice, let's go over one more thing real quick. There's numbers and letters that change, right? So this is really like the branding of it. It's going to be like the generation, and whether or not you can overclock it is expressed by these letters like K and F. So we'll go into that a little bit more. If you guys have questions, let me know. But okay, so let's say we are going to use you can have a price filter over here. So again, what do you want? You want manufacturer, Intel or AMD, ratings, and then you can set it. You can set it exactly how much L2, L3 cache you want. So if you want a high amount, the total power draw. If you only have the budget for a power supply unit that's X amount, you can set the total power, TDP, to whatever matches that. And it's got your micro architectures here. Um, these are, again, all branding mumbo jumbo. Try not to get caught up in that, like the Coffee Lake refresh, Raven Ridge, this Rocket Lake. That's all going to be branding, marketing terms for the actual architecture generation. So let's go to ECC support is error correcting. So if you care about that, includes cooler. Some of these CPUs will come with a manufacturer provided air cooler, and that's going to operate via a heat sink and a fan. So it's not like mine where you're going to have the water loop with the exhaust pump, but you'll have a fan that would be kind of like in the middle, like where my cooler is, and it would just act as an extra. You would have it configured the same way that your fans are, and it would just act as an extra passageway for air to move through to keep that heat sink from just, you know, burning up. So you can also set these by, whatever you want. So let's just say we're going to go with an i5 12400F, right? It's got 6 cores, 12 threads. That's a perfectly good amount for gaming. You'll have no problem doing good 1440p gaming with this, honestly. As long as you aren't too picky about ray tracing, you should be fine with this, right? It's a great processor. It's in a good price range. It's got 6 cores, or should we go with an 8 core, right? You know what? Screw it. Let's say we want to be a little more future proof. I want to make sure that this thing has a little more bang for its buck. Let's go ahead and do an i9 14900. We're gonna go big, right? We got some money. Okay. So now that's our processor. It's a 24 core processor. Boom. A lot of bang for that, right? So now we're gonna go choose CPU coolers. And again, if you have a processor like this that has a high amount of cores and you know you're going to be doing a lot of things with it, you're definitely going to want to look into water cooled over air cooled. So again, when it comes down to these water coolers, you definitely just want to do a little bit of homework outside and figure out how these are rated. But I know for a fact that Corsair makes some good ones. I've been using Corsair myself, so let's type in Corsair. And the IQ Link Titan is a great one. It's got a pump head that displays your temperatures, which is a really cool feature that mine doesn't. Um, on this, you'll get 3 fans, and it's going to tell you the size of the radiator, 360 millimeters. This size, when you're choosing your radiator size for your cooling capacity, you have to keep in mind the size of the case that you're going to use. You're not going to be able to fit a 360 millimeter radiator inside a micro ATX build. You know what I mean? So definitely keep that in mind with how much space you have. And if you have a full size case, you should be good. But if you need to measure it, do your thing. If you guys want me to show you how to measure that specific thing, definitely leave that in the chat or leave it in a comment, and I'll make that a short. Okay. So we're going to add this to our part list. Right now, you're going to see this green bar and it says compatibility. Now that means everything is actually going to be able to be assembled. There's no issues, right? Where you're going to run into compatibility issues the most is actually going to be with your motherboard and your CPU combo, because like we said, architectures change and then motherboard sockets may change. But a lot of the times, what you'll be able to do to combat this is just go ahead and you buy a motherboard that has BIOS update capabilities, because that way, then if you buy a CPU that's more modern than that motherboard generation, you can essentially update the software of that motherboard to be able to interact with the CPU, and then it'll run just fine. I did that with my system. I have a Z690 motherboard, and I think these were built for the 12 series Intel. But since I had a 13th series Intel, I had to update the BIOS via its BIOS updating. Some people will call it flash. So we'll talk about that when we look at motherboards right now. Choosing a motherboard. This is where socket type and all that comes really into play. So you'll notice we picked Intel, so we're going to be locked into the motherboards that will work with the land grid array / Intel socket type. So that's another thing that's really cool about this site is it's not going to show you options that won't work for you because it's calculating its compatibility also. So since we have a nice new, and we're going to go with and we're going full form, by the way. So what you'll notice, you'll see here your socket type, your form factor, that's the size, your memory max, that's how much RAM you can put, memory slots, and then color and a little bit of a rating, right? So you're definitely going to want to pay most attention to memory slots, form factor, and yeah, for gamers, 192 gigs is more than enough. You're only going to run into needing more RAM space than that if you're doing extremely high productivity things. Maybe you're a graphic designer, or let's say you work in animations and you're rendering an extremely high number of CPU calculations consistently. Then buy more RAM. More RAM is always the answer. But yeah, for most of us, you're going to be way more than okay with the standard 256 or even 192s, to be honest. Let's go ahead and pick the. I like Gigabyte. So, and again, I'm just building a system that's like similar to mine. Do your homework on these brands. There's Gigabyte, MSI. Um, I'm drawing a blank right now. What else is there? Hold on, before we lock into Gigabyte, MSI, ASRock, Asus. Asus has Rogue, which is like Republic of Gamers series. So Asus also has some great motherboards that aren't Rogue. So if you're choosing between Asus and the Asus ROG, Republic of Gamers is basically Asus's like more beefed up motherboards to support gaming features, right? So let's do this. And make sure you get one you like the look of too. Because remember, I showed you guys my PC. I have like a black and white motherboard and a black and white build. It's kind of like it's all black and white. It looks consistent, real stormtrooper type beat. I absolutely love it. But I curated it. I built it myself. So make sure you like the motherboard you pick. But Gigabyte has some great ones. Let's see, this Z760 Eagle, cool, looks great. It has a nice big I/O. This is where you're gonna plug everything into. You've got your 4 RAM slots. You've got your connectors here, power connectors. You've got your PCIe slots here, and your M.2/NVMe slots. So this is a nice, good, modern motherboard. The other thing that you might want to consider when shopping motherboards is Wi-Fi capability. If you do not sit right next to your router and you're in a house where you can't necessarily run cables to and from your bedroom, your office, or wherever you're playing slash working at, definitely go ahead and turn on the filter down here, and it'll just only show you ones that have Wi-Fi capabilities. So there's a lot more with these, but we're gonna do a whole motherboard episode also, so you guys understand motherboards because I'm kind of a nerd with them. Wireless networking, Wi-Fi 7, Wi-Fi 6E, Wi-Fi 6, Wi-Fi 5. Most of us, to be honest, are somewhere between Wi-Fi 5 and Wi-Fi 6, maybe 6E at this point. Wi-Fi 7 is pretty new, so there's again, if your router inside your house is a 5 gigahertz router, there's no need to spend an extra $120 on a Wi-Fi 7 motherboard because you don't even have the broadband capability to be able to take advantage of that. So make sure that your Wi-Fi networking capabilities matches your router setup at home, and if it doesn't, then make sure you upgrade accordingly. So let's go ahead and pick a motherboard. So I like this one. It's nice. It's modern. It's got a good I/O shield. Cool. Looks good. It's got a good design. Let's add it to the part list. And we're still compatible. So that means that it's going to be good to plug and play. You won't have to do any BIOS upgrades, and you're good. Memory. Remember the difference between memory and storage. It's very crucial. We spoke about that in the last stream. So we're going to be picking RAM. If you guys have been on tech YouTube at all, you've probably seen a crazy amount of, oh my gosh, RAM prices, and OpenAI is destroying the RAM market, and oh my gosh, what are we gonna do? Yeah, you kind of just got a ball when it comes down to RAM, because you can't really you can't really cheap out on RAM, right? It's such an important component. And you'll notice here that it has speed, right? DDR5 6000. So what does that mean? DDR5 is double data rate, um, which is another direct indication of how fast it is. So you'll notice that it's only showing us DDR5, and that's because why? If you guess the motherboard, you got it right. It's because we have a DDR5 socket type in our motherboard. You can go DDR4. I use DDR4 right now, no problems with my system. But the upgrade path of DDR4 is dead. There's not going to be more DDR4 motherboards coming out. So if you're building a system and watching this now, I would say go ahead and just get into DDR5. It's faster, it's smoother, it's just the next gen. I haven't heard anything about DDR6, but I would absolutely love to if anybody knows about that. So yeah, back to choosing our memory. So we're gonna have our DDR5 options. Your modules is how many pieces it comes with. So is it one RAM stick or is it two? You definitely want to get a double kit, because most motherboards in the manufacturer's manual, they're going to give you an optimal RAM configuration. So when you're setting up your RAM sticks, it's going to tell you not only that it's ideal to use two, but it's also going to tell you which slots to use it in. And it'll give a brief explanation of, a lot of the times it'll give a brief explanation of what can happen if you plug RAM into the wrong spot, which could lead to boot problems or could lead to stability issues, crashing, all kinds of bad things can come up with RAM not being seated properly or seated incorrectly. So let's say you have it in the right slots and it's in the right configuration, but you just didn't click it down right, or you got a cheap motherboard that doesn't come with the little latches at the bottom so that when you press it in, it kind of snaps and it's in there. Um, it can lead to all kind of issues. So definitely check your seating and make sure you understand how having two modules is usually best. Color is literally the physical color. So if it says black, you're going to see that it's black. If it says white, you're going to see that the actual RAM stick is white. CAS latency, right? So let me go ahead and just give this a quick Google, and then I'll explain it. CAS latency is the number of clock cycles that a RAM module takes to respond in a data request from the CPU. So in other words, latency equals lag, right? So the lower CL number you have, the less lag there is between your CPU and your RAM actually receiving those instructions, whatever data it's transferring back and forth, right? As we go higher in the DDR ratings, though, the CL does go a little bit up. So you'll notice that if you're shopping like DDR4 Caswell latency, and then you're looking at DDR5 Caswell latency, you're really almost never going to be able to get like the CL16s and like the CL14s that we had on DDR4 in DDR5. Is that like a major bummer, and does it like totally ruin your experience? Not at all, dude. Don't even trip. It's still, we're talking milliseconds here too. You have to think of how fast or how slow the human eye can even perceive what we're seeing, right? So milliseconds is usually, you're talking milliseconds, okay? You can't be that picky, dog. But yeah, like, and then the most important thing about RAM, of course, is the RBG on the top. RGB on the top. You need it to look cool. So no, I'm just playing with that, by the way. So let's go ahead and pick some RAM. Do we like G Skill? Do we like, what do we like? What do we like? G Skill makes some cool looking one. In this market, I recommend organizing it to buy The price, man. Go CAS latency down. Price. 36 is good. Try to go 36 if you can find a 34. I don't know. But again, like if even the difference between 36 and 40 is not going to be like the amount of RAM that you need, like I said, is up to what you're doing with your system. If you're just doing basic stuff on DDR5, 16 gigs should be fine. You could probably just get 2 sticks of 8 GB each. If you're gaming or you want to stream or you want to do any type of productivity that might require multitasking, go for 32 gigs of RAM. Artificial intelligence engineering or anything more CPU intensive, um, try to go for 64, maybe even more, right? So again, it really depends on your use case. But for our system, we want 32 gigs. So we're going to choose two 16 GB sticks, and we're going to go with uh, 38 casual latency. This is fine. Crucial Pro, right? Let's go with the. Yeah, that's cool. We'll do that, right? Okay, so now you have your RAM, right? And you have enough to run your system. You have 32 gigabytes of RAM. And your storage is next. So remember the difference between storage and random access memory. The storage is hard drives, SATA drives, SSDs, NVMe's, what have you. Just go NVMe, right? Hard drives are great for data centers and redundancies and RAID arrays and playing around and doing all those kinds of things. There's nothing wrong with optical hard drives, but they're clunky and they take up a lot of space, and you're working with limited space inside your actual case of your computer. And having too many hard drives and physical SSDs kind of stacked back there can be a real headache. Some cases do a great job of providing like little brackets where you can actually rest your SSDs, or they have like a hard drive cage where you can just kind of slide it in. But again, if you need a lot more storage, it's almost certainly better to just go for a motherboard that has multiple NVMe slots, and then you can upgrade as you need because they're so much easier to install. The speed difference is way, 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 way faster. Like your mid tier NVMe is going to beat your top tier SSD in speed. You know what I mean? So, and they're really not that much. You can get a 2 terabyte Samsung 990 or like Western Digital Black SN850X. I have WD Black. I think WD is also used in PlayStation systems. So really, really good for gaming. Everybody knows Samsung. Creators love and trust Samsung. And this is another thing that's going to go and drive the price up based on your use case. So you'll notice that's kind of a recurring thing now, is like the more stuff we need to do with our PC, the more expensive it's going to be, right? So let us say that we want 1 terabyte, and really all it comes down to with these is like you can have your read and write speed. And I'll go over that real quick because that is pretty important. So you'll see here full disk writing speed, reading speed, sequential write through speed, sequential write throughput, right? This one, these are probably the most important. So, what is sequential? Oh my God, you just saw my brain blank in real time. Sequential write throughput. Throughput. What is it? Let's make it simple. Silicon write throughput is a measure of how fast it can record large continuous blocks of data into adjacent locations. The easiest way to think of this is the loading screens between your video games, right? So if you have one that's really fast, less loading times. How fast it can actually generate and write that data, right? So the faster of a speed it is, the faster it's going to actually write the data, which is important because if you're doing things that are, I mean, almost anything is going to need you to write data. So how fast you can do it is obviously going to be very important. So this one, for example, is almost 7,000 megabytes per second, which is, again, per second, right? That is per second, which is blazing fast. And at 2 terabytes, that's more storage than I'll need for having, depending on the file size, let's say 8 to 10 games on there, as well as a couple apps that I use daily, right? So that's fantastic. We're going to go ahead and throw it in a bag. And you'll notice here, another cool feature of PC Part Picker is that they're going to give you different outlets that are selling this part. So you'll notice what you're doing is actually compiling a list maybe from different places because they're going to give you the best price on that particular component. So that is a great hack when it comes to saving a little bit of chicken. So Amazon right now has the best price at a total of 358. So why would I want to go buy it from B&H for 620? I don't know if that's an error or what, but I can get it from Amazon for 358. So I'm gonna throw it in a bag. You can always check it too. See, you guys already seen that I already have one. I already bought it. I'm not fake. All right. Video cards, GPUs. What it do? Okay. So GPU specs explained, baby. This video is very long. I love Linus's channel. How to choose a GPU. I mean, we're gonna talk about it right now, right? But I want to break down the most important things, right? So uh you know what, let's just do it together. Let's just do it together and I will explain it to you. We don't need to watch a video on this. Let's click a graphics card and let's break it down, right? Let us click the RTX 5070 and let's break it down. All right, let's make it simple. So you're gonna notice it has its chipset. So the chipset is directly correlated to the generation. So different generations have different chipsets. Remember how we talked about architecture on a CPU? It's kind of like that. So the architecture of a GPU will also change, right? So the chipset of a GeForce RTX 5070 is not the same as a 4070 and is not the same as a 3070, which is what I'm using right now. Um, these are it's almost exactly like the CPU. How the better or the more modern the generation is, the more recently they designed the architecture of that board, how it functions, how it's laid out, what it's supposed to be capable of, all that good stuff, right? So most of the time, and my voice cracked because I'm lying. Honestly, you really got to do your homework on GPUs, and that's the next site I'm going to bring because new architecture on GPUs is not as cut and clean as it is with CPUs. Most of the time, you can trust that the new CPU is going to be faster than its predecessor. But GPUs get a little bit mickey and tricky. They can kind of they can kind of differ with your actual setup, and so you're going to want to compare it to you're going to want to put two on the table and compare them. So I'll teach you guys how to do that. The memory of the GPU itself is its VRAM. VRAM, right? So what is VRAM? VRAM. We talked about this briefly, but it's the dedicated high-speed memory of a graphics card that stores its image data, textures, and frame buffers, rendering to a display. So the more VRAM you have, the more storage you have available for your GPU to operate. More VRAM, the better. A couple years ago, when I built my system, 8 gigabytes of VRAM was kind of like the gold spot. Like that's what you needed to run, HD gaming at smooth frames, and you were kind of good. Now, 8 gigabytes of VRAM is like the bare minimum. To be honest, 6 gigabytes of VRAM, don't even do it. Anything below 8, don't even think about it. 8, even now, is at a spot where it's like almost not net. It's almost like you don't want it, right? The reason why is because as we do more things with software, as games get coded more densely and more just yeah, as they get coded more densely, it's going to take more computing power to run them at their optimal resolution. Then, like for example, Hogwarts Legacy is a great game. It looks phenomenal on PC, and playing that with 8 gigabytes of VRAM, that game is engineered to have phenomenal ray tracing. Same kind of thing as Cyberpunk, where it's got this coding where it can let you see lighting that looks stunningly real to the point where it looks like it's like you're watching a Harry Potter movie. But if you don't have a GPU with enough VRAM to handle those settings, you got to turn everything down. Now, if you don't care about how the game looks and you just want it to run fast, frames per second is your thing, then VRAM is not going to be something you care too much about because you can always just lower your settings and provide yourself a faster experience. But if you're like me, where you really care about how games look, you really care about how your computer looks, and when you watch movies on your computer, you want it to look phenomenal. And when you play games on your computer, you want it to look phenomenal. Or maybe you design jewelry like I do, or maybe you work with generative AI, or you like the way things look. You just like things to look crispy and buttery and ooh, rap, flip, dip, the hibbity do, rap. Then you need more VRAM. It's that simple. So I'm even thinking about upgrading my system. I love the 3070. It's a beast, and I have had no issues with it. But I need more VRAM. I want at least 16 gigs of VRAM in my next graphics card. Um, and that's a really important thing because when it comes to that, a lot of the times AMD is going to give you more VRAM for the similar price point. So you'll notice, let's see, like, let's try to find 5070 Ti. Oh, and then when we're in GPUs, we also have Intel. Intel makes GPUs now. They have the Arc series. I haven't heard too much about them, good or bad. I'm being completely honest. I think they just kind of skipped my radar because I'm gonna keep it real with you guys. I'm an Nvidia fanboy. I absolutely love RTX. I love ray tracing, and I'm really big on how things look. So you'll also notice from other tech YouTubers, they'll kind of put it like this, right? If you care about how things look, go Team Green. Nvidia's path tracing and ray tracing and shaders is almost unbeatable. The actual optical performance of an Nvidia graphics card is hard to beat. If you want smoothness and performance and raw power when it comes to gaming, a lot of the times they're going to recommend AMD, and that's because at the same price point, if you're spending $500 on an AMD card or on a Nvidia card, most of the time you're going to get a couple gigs more of VRAM from that AMD graphics card. So it really comes down to use case yet again. Um, so let's go ahead and just say we're going to pick this 5060. There's a couple things you want to consider. You now know what GDDR is graphic double display rate. So that's directly correlates to how fast it is. Your memory is VRAM. Core clock works the exact same as a CPU. Boost clock works the exact same as a CPU. Measures the same thing. And then your interface is going to be PCIe is Peripheral Connection Interface Express, I think. If I got that wrong, please leave it in the comments because I'm horrible with acronyms, but I understand concepts. But the PCI is your connection to the motherboard, so where you're actually going to plug in your graphics card at. So yeah, but again, compatibility is not really much of an issue when you're using PC Part Picker because it's going to flag those things for you. So let's go ahead and throw a let's go price and let's see what graphics card we can get for $500. I got $500 and I want a good graphics card. So you'll notice that you'll have your options of your Radeons, your GeForces, and then their architecture, the 3 series, the 4 series, the 5 series. Radeon works the exact same. The higher the number, the better it is, essentially. So let's say that we love ray tracing, and we want to do ray tracing, and we're gonna do this 5070 12 gig. It's out of stock. Bummer. 5060 Ti with 16 gigs. Cool. I'll take it. It's a little bit more expensive, but 16 gigs of VRAM, more than enough for what I should be playing on a 1440p setup. I'm going to add it. So now you've got all your important PC components, right? Now you get into the things that are a little more fun after, or you know what? Let's do power supply first, and then we'll do the last ones. And then by that, I mean, I'll show you how GPU benchmark works, and you guys would be good, man. You can take this and refer back to it, watch it a couple times, do whatever you need to do. Hit me up. Um, I'm always available to help you guys out. And yeah, you'll be able to use this to just be able to build a computer online, or hey, go to Micro Center and tell them, yo, I watch Silicon Made Simple. I'm ready to build a computer. Here's all the parts I want. They have everything there too. It's kind of like a Best Buy, but it's like Best Buy only for like real PC enthusiasts, I want to say. How would you guys describe Micro Center? Let me know. It's a cool place though. I love it. So we'll go ahead and go with power supplies. Now remember that thing we talked about? TDP with your CPU, power, heat, more heat, cooling. I went over that very fast because it's super simple. Um, Here's the thing with power though, that's the most important. We'll go over what these efficiency ratings mean. That's not the most important. The most important is its wattage and how much power it can actually generate. Because if you have a bunch of components that put out a 780-watt power draw total, and then you buy a 750-watt PlayStation unit, power supply unit, guess what, bud? You're in trouble. You want to make sure that you have an excess of a couple hundred watts just to be safe, right? How do you figure out how much watts your system runs? Well, there's a website for that. I'll show you. It's actually called, you can just type it in on Google, PSU watt calculator. PSU wattage calculator, right? There's one on Newegg, there's one on Seasonic, there's one on Corsair, whoever you like. Cooler Master, Be Quiet. A lot of these really popular PC manufacturers have a power supply calculator. So use whichever one you're comfortable with. Let's use Corsair. Select your GPU. We have, what's the GPU we have? What's the GPU we picked? Did we forget? I did forget. We have a 5060 Ti, right? 5060. I forgot to type. 5060 Ti. We have the MSI GeForce, MSI Ventus. 16 gig, Ventus 3 times. That's ours. Okay. And what CPU did we get? We got the i9. Which one did we get, guys? We have the i9 14900K. So you can type that in, 14900K. And make sure you put the right one so that you get the right results. Okay. Intel Core i9 14900K. Yeah. Okay. It's going to ask you a couple questions. Are you using a small form factor case? No, baby. We are full size. Are you overclocking your system? No, we're not. No need. They're going to recommend what you need. Why? It'll give you a couple things, right? So your total power draw is going to be under that. An even better one that I like to use, because this is kind of just going to recommend like a strict Corsair one. Um, Newegg will also like show you your actual number. So let's do it one more time, and you'll notice that Newegg's is a lot more in depth, and it's going to ask you for more of your component information. So we have an ATX motherboard. Our GPU chipset series is not Intel, it is NVIDIA, and we got the 5060 Ti. We've got the 5060 Ti. RAM, we are running 32 gigabytes of DDR5. SSD, that's your solid state drive, not installed. Okay, we do not have a SSD. Hard drive. No optical drive. That would be like a DVD player or something. I don't know why they don't give you, but okay. So even if we did have it, let's compensate for an SSD, because an NVMe is an SSD. Excuse me. I was just looking for an NVMe specifically, but we have 1 terabyte plus. So throw that in, and you'll notice it didn't really change nothing, right? Even if you had two, not going to change a whole lot. Why? NVMe's don't draw a lot of power. If you had two GPUs, that would blick it up, right? So your wattage is going to be somewhere between 500 to 599 watts at full capacity. So that means that your 750-watt power supply unit would be enough wattage to be able to handle that computer system. If you went up higher than that, you would even have more room. So there's nothing wrong with getting too much power, I guess, but you definitely want enough. So now we know that we are looking for at least a 750-watt power supply. Corsair, this is a great one. And the other thing that comes with power supplies, let's talk about efficiency rating. 80 plus gold, bronze, platinum, right? So 80 plus is its efficiency rating is how efficient it is, right? Because they don't actually get 100% of the power, right? Every time that we send power through a cord or send power anywhere, there's a heat mechanic that goes with it. Power that gets lost as heat is actually calculated for. And so then they kind of will tell you how much of your actual power is being utilized versus lost as heat. So the more efficient it is, the more efficient it is at utilizing the power. The efficiency rating is going to be a numerical indicator of how that works. So it kind of works like metals. Bronze is going to be the least efficient. I don't even see silver on here. I don't. Now that I think about it, I don't think I've seen a silver rated power supply. I don't know if they don't make them, but go for gold. Platinum's cool too, obviously. But you want gold at least, because you want to use your power and not lose your power. So 80 plus gold is going to be more than sufficient for you. And then you got your wattage right here. So again, form factor ATX, we have a full size ATX case that we're going to select, so no worries there. And yeah, the only other thing you want to focus on is what I told you about when it comes to the wattage rating. So we know the wattage, 750 is cool, $90. Oh, I almost screwed you guys out of something major. You'll notice right here, this section says modular, right? Modular versus non-modular is related to how the back is laid out. A fully modular power supply, you can unplug all the cables. and you can plug in SATA cables, and generally they're going to have more slots for more peripheral devices, things like that. But that's the main difference is whether it's modular or not. Modular power supply. If it's not modular, it's going to have a cable that's fixed to it. So I like fully modular because it helps with cable management. It helps with being able to do more. So I would actually recommend fully modular. You're not going to save too much money by going with semi-modular or non-modular. You might see non-modular power supplies on older systems, legacy PC builds, your grandma's computer. I don't know, bro. I ain't never seen them. I'm 30. So let's go for the 750-watt Corsair ATX power supply. Boom, 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 bop, bam. We're gonna need an operating system, right? And that's like Windows, Linux, whatever. I'm gonna go over um, operating systems, how to upgrade, and keys that you guys can use to upgrade your system. So stay tuned for that in another episode. But again, then there's a cost, of course, with your operating system. You don't need to put that in here. I wouldn't shop for operating systems here because I'm gonna give you guys a hack on how to get them a little cheaper. Monitor is the next best, most important thing. The most important thing about a monitor is the refresh rate, other than resolution. So by this point, you've already decided what resolution you're intending to go for. With a computer like this, we're going 4K. We have a CPU with 20 something cores, and we've got a brand new 5th series NVIDIA GPU. So there's no reason to get a 1080p monitor. You're constricting yourself. You're giving yourself a bottleneck. It's like wearing glasses if you don't need to. Resolution, we want 4K. So 3840 by 2160, also known as 4K quality. Refresh rate. What's that, man? What's that? What's that? Refresh rate is the refresh rate, which is the rate at which it refreshes. No, I'm kind of being serious. The refresh rate is frames per second. 60 hertz is 60 frames per second, 240 hertz. So, like, the more hertz, the more smooth and the more fluid you'll be able to actually get the movement of the screen to look, right? Your response time is also pretty important. Again, these are a matter of milliseconds. So, are you going to notice your homie system? He has a half millisecond response time and yours has a 1 You're not going to notice that, bro. Stop lying to me, pretending you can see millisecond intervals. Stop. Anyways, I'm just playing with you. If you can, that's phenomenal, and I would love to have a conversation. Um, Response time is pretty similar to latency. Remember how we discussed it in terms of like RAM, how it actually responds? That's your normal response time. I have a 1 millisecond monitor. Again, that doesn't matter too much. My recommendation: 3 milliseconds or less. Super, super, super buttery. Um, go for one. Don't get caught up in this. It's not too important. Your panel type is going to be the technology. So whether it's wide organic, lead emitting diodes, OLED, IPS. That's the type of panel that you have. The better the technology of your panel type, the more crispy the colors are. Things might pop a little better. Again, you'll notice that a QD OLED is probably going to be much more expensive than an IPS, right? Are IPS monitors bad? No, not at all. Um, so really, technology is going to be your main price factor. But again, I shop mainly by resolution and refresh rate. Um, so let's say we want one that is going to be. We don't need that. Let's look for one that's 144 hertz is the monitor that I have. I absolutely love it. See, you have so many options, and like you'll see over here, panel types. response times, refresh rate, resolution. So let's filter. We want 4K. We're not manufacturer biased. Um, any of these are fine. There's a lot of different ones. We're gonna weigh them out anyway. So your screen size, how big do you want it? Do you want a smaller one? Do you want like a massive? Are you in like a lab where you got like a whole man cave to yourself and you want a massive monitor? I don't know. The other thing to keep in mind is whether you want a curved monitor or not. Right? So I don't. I'm gonna try this. I might look kind of crazy. I don't know if you guys can see, but my monitor is actually curved. It's kind of got a curve like towards me, right? So that when I sit in front of it, it's got a little bit more of an immersion factor. I really like curved monitors. I think they're great. I go back and forth. My workstation at work is not a curved monitor, and this is a curved monitor. Do I notice the difference? Yes. Is working on a flat monitor off-putting? Not for me personally. Um, they've even got some that fold out now. So the actual physical form factor of monitors is changing, and it's blowing my mind. But for our we got to do a video on monitors because there's so much to talk about. But let's go. Let's see. We want 144 hertz, right? Because we want a smooth, real good gaming experience. Refresh rate. So we're gonna change this up to 144. Okay. LG's got one, a 32-inch, 4K, 144 hertz with 1 millisecond, and it's not a bad price at all. Let's check it out. Yeah, it fits our criteria. I mean, down here you'll see a couple reviews. No complaints here, and it fits everything we need. So you have your options here. They have it on Amazon. They have it on LG. But for our purposes, we're gonna throw it in the cart. So you're gonna click the add button. All right. Now we have just completed building a whole PC from head to toe. If you went and bought all these parts and delivered them to your doorstep, you would be ready to game the next day. Um, that it's really that simple. If doing this is not your cup of tea and you absolutely must buy a pre-built, um, I think there is a few good sites that I'll put you guys onto. iBuyPower is not bad at all. Um, iBuyPower is run by a YouTuber. No, it's not iBuyPower. Don't. I'm sorry. Not that you shouldn't go there. You see what I mean? Like these. Here's the problem with. I'm not gonna. Don't buy pre-built. Okay, I changed my mind. If you need to buy pre-built, don't. Watch this video again and go build your own. Here's the problem. These a lot of the times have like proprietary motherboard mounts and weird RAM and all kinds of like literal screws that are proprietary to that manufacturer. So that God forbid anything go wrong with your system, you open it and it's like, what am I looking at? You might have to replace entire parts, and then it's kind of like having to replace the engine of a car at a certain point. It's like, well, why don't you just buy a new car? So to be honest, unless you can really go play with the system and you're like, yo, I sat at Best Buy for an hour and gamed on it and it's everything and I absolutely love it. Um, then you could then I guess, but pre-builts are never you're never going to have the advantage buying a pre-built PC over somebody who curated and built their system. And that's the whole point. I will give a shout out to the MacBook Neo. That's a great little laptop. It's out the box, ready to rock. Um, that's like my only like pre-built computer recommendation right now, MacBook Neo. Other than that, G, figure out what you want. Step one, figure out what you want. Step two, figure out your budget. Step three, go to PC Part Picker. Build it. You're gonna get the best prices that you can for the time that you're shopping, and then you can. Most of the shipping is free. Um, you shouldn't inquire too many costs over your total cost of the system. So again, you might look at this and say, dude, this is crazy. Like $3,000 on a computer is way too much. But what's way too much for something that you're going to be able to use to make money, use to work, use to entertain yourself, and it's going to last for years with an S over a pre-built that has no longevity of operational success, to be honest. You can even go down here and they have, a spot for headphones, keyboards, speakers, mice, webcam, all your peripherals, case accessories, all those things. Um, yeah, cases is all up to you completely. You know what? There's a little bit about cases that we should go over. You already know the case sizes. We talked about that. The side panel being tempered glass, that's what you see here so that you can see inside your system. Usually looks cooler. If your system's like tucked into like an office space and it's like low and you're like super sophisticated and don't care about lights, then tempered glass on the side isn't going to be important for you. But really, when it comes down to picking a case, just pick one that you think looks cool. And then there's two things that you're going to want to look for at the case. I would type in the name of the case and the model of it and type in the terms cable management so you can actually see what it looks like in the back and how they route the cables to and from the motherboard into the back and down to the CPU, not CPU, excuse me, and down to the PSU because it's all wired in the back. So you don't really see it in the front. Remember how I showed you guys my system on that one stream and my wires just look like those two chunky wires that you can see? If I scoop my 3D printer back, you can kind of see what I'm talking about. So you'll see just a few wires. That's because most of it is in the back, actually behind the motherboard in a space about this wide. And so how those cables are routed from the motherboard up and around slash into around the sides, through the back, whatever, and then down into your chamber that has your power supply unit where that's mounted is very important. And more modern cases are starting to incorporate cable management into the design of the case, which is really cool. So I would just look up the model and the case followed by the terms cable management. And other than that, Jay's Two Cents does a really cool thing where he like tests the airflow by using colored smoke. If he has one of those videos, check it out. If not, then kind of just study that same concept, airflow. Fans is what we talked about last stream that'll really help you out. How you configure your fans, how many fans you can fit inside the case, where they're put in the case, whether and how you configure fans. I mean, are they sucking versus blowing and in which direction that's happening, intake versus exhaust, right? So that's really it when it comes to cases. Find one that looks cool. Find one that looks like its cable management isn't too much of a nightmare and it has good airflow, and you'll be good to go, man. A lot of your cooling power is going to come from the fans on your GPU. A little trick for GPUs is buy an overclocking version because even if you're not going to use the overclocking features, a lot of the times those overclock capable GPUs come with advanced cooling capabilities. So I always buy overclock GPUs and I don't overclock. It's just for the extra cooling because those fans tend to be a little chunkier, might run a little faster, whatever. Um, but again, a lot of your cooling power comes from your fans, how they're configured, where they're configured, the cooling capabilities of your CPU cooler and your GPU and the case. And that's kind of what moves air through and past the components that it needs to brush past and out where it needs to come out. Again, mine comes out in the back and in the top. So I've got 3 fans intaking, 3 fans exhausting, and then my GPU has its own fans. Um, that's kind of how my cooling works. It's always going to be a mixture of air and water. Um, there's really cool like builds that have water pumps, and it's like a water reservoir that you fill up with like a certain type of liquid. Um, cooling can actually get crazy because there's submersion cooling. I'll show you guys this real quick because it's really cool before we get off. These things, AI. Uh, I forgot. I don't. I'm like blanking on it. Data centers are like actually starting to be moved underwater because of cooling. So like imagine your PC so hot you need to put it underwater. I'm trying to spare details because this is another cool episode I want to go into. It's all about cooling and how it works. But yeah, man. So you can get to the point where you have a little bit of water, you have a medium amount of water, and then your computer is in water. So yeah, I think that's really it, guys. GPU benchmark site. I didn't go over it because it's super simple. All you need to do is use the comparison tool. So you can click right here, click compare, enter the 2 GPUs that you're thinking about buying, and it's going to give you what's best about each of them. So we can compare like the 5080 with the 5070 Ti. And it's going to tell you which one is better and which. Oh, the 5080 has better reflection, better multi-rendering, better end body, blah 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 blah. And let's say you want to do you want to compare it with oops. Let's say that you want to compare it with an AMD GPU, you can also do that. So, yeah, whatever GPU you want to use. Let's say you want to compare these two, right? I was thinking about buying this old RX 7600 or a 5070 Ti. Which one's better? You know, like that was a stupid example, but you see what I'm getting at. You can compare the newest architectures together, the 5090 with the RX 90 whatever 100. I don't know what they're on now. But yeah, now you guys know the advantages. You nerded out with me for almost an hour, and you guys should be able to understand how to build your own PC. So I'm gonna stop sharing my screen. I'm gonna look at you and say thank you guys so much for spending time with me. If this was helpful to you, leave a comment. If there was anything that I missed, leave a comment. If there's anything that you're like, what is bro talking about? That's completely wrong. Leave a comment. Like I said, this is a community where we're gonna learn together, and yeah, now you guys can go out there and, like I said, go to Micro Center or hit up PC Part Picker, build your PC, build your system, and get it cracking, man. However that is. So, Silicon Made Simple. This has been another great episode. We will be back Thursday with I think we're doing labs. I'm pretty sure we're gonna do labs unless I change my mind again. But yeah, labs Thursday, all right? Until then, be safe.